the assembly of this wall system,
Yeah,
which,
because it's
as you
thick.
can see, is pretty robust. I mean, we have four inches of outboard continuous insulation, and this is wood pulp. So from afar, if it looks like wood, it's because it is.
Yeah. It's not a fat house, it's just big walled.
We've been plugging away at renovations here at Flock and have been most interested in the latest building science around energy efficiency and better building materials. So when we caught wind that our friends were designing and constructing a passive house build in the area, we wanted to see how they were doing it. Passive house design is a holistic set of design principles for attaining solid energy efficiency while creating a comfortable living space for its occupants. Though passive design houses may be around 2 to 10% more cost up front, they typically achieve 90% energy savings in the back end. We'll talk with the owners, architect, energy consultant, and builders to deconstruct how this passive house in the Finger Lakes of New York is being built.
Well, this is quite the project. So you have been working on this since 2021, you said?
Yeah, we came up and we started looking at property around this area in December of 2020. So yeah, so it's been a while.
Then you found this plot, and then did you always want to do a passive style home, or was this something that you...
We debated.
Yeah.
We knew we wanted to do something that performed really well,
Yeah.
but
I think high performance was the goal.
Right.
Right. So get your energy bills down, kind of a little bit of independence from the grid. We were looking for high performance, and we have a friend who's an architect in the Hudson River Valley. He built his own passive house, and we were like, oh yeah, we should do that.
That's
So
great.
I think passive house made a little bit more sense since it was more about performance, because we're the ones who'll be paying these energy bills ad infinitum. So yeah, I guess the way I was thinking about it, you know, if your time horizon is long enough, like investing another 10% into like insulation and kind of like the membrane and all the performing parts is worth it, because who knows what energy costs are going to be.
Right.
So yeah.
You enacted on it in 2021. When did you actually start shovel to the ground?
Yeah, I think it was June of last year. I don't think they actually poured the foundation though, September?
I think that sounds right.
Yeah, I think around September is when they started with the foundation.
And then when do you foresee this done? Because it looks like it's a work in progress, but it's coming together.
Well, end of June, because otherwise we'll be homeless, so yeah.
Oh, so you already like sold your
No, our lease
Yeah,
runs
we
out.
have
Someone
a lease
else
pretty
is
close here.
yeah,
So we
already
have to
lined
be
up
out,
to move into there.
So, okay, so in like basically a couple months, you're planning on moving in here.
2 to 2.5, yeah.
Yeah.
After meeting with Rachel and Sean, Noah, the architect and CEO of Stream Collaborative, stopped by to share how the design of the house came together.
My name is Noah Demarest. I'm an architect with Stream Collaborative, architects and landscape architects, and I am the designer of this building, this passive house.
Is this one of the first passive houses that you've worked on, or?
This would be the first officially certified passive house that we've worked on. Craig in our office, who's a builder, had previously built a passive house. So we've been building and designing to kind of passive house standards for quite a while. But this is the first client who is like willing to actually go to the certification level, which is pretty exciting.
Yeah, I mean, talk to me about that, because Stream Collaborative, I know that you've been working on a lot more sustainable design principles.
Mm-hmm.
This obviously, you know, rolls into that in a big way. And can you tell me a little bit more about the other things that you kind of dreamt up with this project as well?
I think the biggest thing is thinking about embodied energy. So what that typically means is minimizing things that are high carbon, high embodied energy, such as concrete. So trying to minimize how much concrete you're using, as well as foam. Foam is something that we don't love to use. Sometimes you're sort of forced to use it in certain applications, let's say below grade or whatever. But we try to eliminate those things as much as possible, and we really focus on, we call it the plant-based diet, for homes. It's really using as much as possible cellulose-based, meaning wood studs, wood insulation, cellulose insulation, just as much as possible. So we're trying to offset some of the embodied carbon in things like the concrete that we're also kind of forced to use to a certain degree below grade, So yeah, it's this constant kind of balancing.
Yeah, I mean, but I think that's interesting because, you know, building and construction is such a legacy industry that you have a lot of legacy products and maybe not so much innovations in the ways that you want. As you were saying, like you have to maybe use the foam below grade, underground or whatever. But actually just by putting it out there and like making an effort where you can, and of course, you know, you're always at the behest of your client too. You know, what the client could, you know, wants to do or afford or anything along those lines. Or where you could source, because maybe some of these things are not just coming from down the road, for instance.
Yeah, and also what the builders are familiar with, because a lot of times we really try to incorporate the builders in the project, in the design phase as early as possible. And they do help shape and make decisions in terms of what their preferences are, what the availability of subcontractors and so forth. So despite your own best intentions to be as green and sustainable as possible, there are limitations just based on who's available to do the work, for sure.
I mean, that's really smart. And I think one thing that we don't often think about is that sometimes architects and builders are in their own silos. And, you know, I hear some, you know, builders where they're like, they get the architectural renderings and they're like, oh boy, you know, that type of thing. But the fact that you incorporate some of the builders and that Craig, who's one of your colleagues, had actually built this way before, I think really helps inform decisions.
Yeah, in fact, I think everybody on our team is at least an amateur builder. We're all DIYers. So we all have gotten our hands dirty with our own projects, and I think that really does help differentiate perhaps our firm from other firms when you have that experience and you sort of understand, you know, just what the practical limitations of materials are and availability of materials. It has helped us a lot, I think, in terms of our approach. This is not something we learned here, but something we have done, and something we would like to push even further is this shallow frost-protected foundation.
Yeah, talk to me a little bit about that.
Yeah, so
this doesn't go deep into the ground, right?
Actually, you see the bottom right there.
That's
this
crazy.
has not been backfilled to its final elevation.
Yeah.
We did use some foam, and there's an insulated concrete form here. That creates the edge insulation for the slab. So it's a monolithic slab pour. So the floor slab poured into the perimeter footing, it's all in one pour. And it's only gonna be 12 inches or so below grade. So the finished grade is somewhere up here. And then we have this wing of insulation that comes further out as well.
And then how are you going to cover this? I'm just thinking about like animals and things like that.
Yeah, so this will get a gravel mulch essentially all the way around, and that'll be the finish. And then any landscaping that we do, we like to keep outside the drip edge anyway of the house, so it's getting natural rainfall.
Right.
But you also don't want that. Plantings, you want to keep as far away from the building as possible just because of insects and different things that can kind of move, and also moisture issues on the siding. So just creating some breathing space between the building and the landscaping. So yeah, just a gravel drainage drip edge.
And then typically in this type of climate, I'm assuming you actually normally go down into the ground below the frost line, correct?
Yes, exactly. So this is called shallow frost protected foundation because we're only about 12 to 16 inches below grade, but frost depth is 48 inches, so 4 feet down.
A lot of digging.
It's a lot of digging, and it's a lot more concrete as a result. So this is one of our things that we're doing to try to minimize the amount of concrete on the project. And as I mentioned, this was not new for us necessarily, but it is starting to push in this direction of we can push it even further. And this is kind of going back, I think you had mentioned like, there's kind of these traditions of building and the expectations from the builders or the owners or whoever, but there are ways to do this without any concrete at all. But that's considered a bit far out there and a bit crazy.
Usually you go below the frost line. That's how you prevent, moving and stuff to occur. How is this working to minimize that same effect? Why don't you have to get underneath?
So there's two things that are happening. One is we're taking the foam out horizontally, and so what we're doing is we're creating a warm bubble of soil underneath the building. And so that bubble of soil, which is naturally, say, 50 degrees, we're ensuring that it stays around 50 degrees.
And is this like an R, like what value does it need to be?
Yeah, so I think you need about R10 of that wing. And there's again, a complicated formula formula depending on how far out you go or how deep you are to determine exactly what that R value needs to be. But the idea is if this soil outside the foam is 0, there's this temperature gradient that goes down and under the footing that we want to just kind of keep that above freezing, essentially.
Fascinating.
And how would it work? Because you're saying there's ways to achieve the same result without the concrete. What would that system look like?
Well, I'm really interested.
It's still experimental.
Yeah. Well, there's a couple of things. One is I really love the idea of using natural stone. And I think, so many of our homes around here and buildings around here, barns, were built with natural stone. There's no reason we couldn't just build a stone foundation. I mean, it would really minimize your concrete. So that would be exciting. And then the other thing is we don't need to use a concrete slab. There are some neat alternatives to just doing essentially the same gravel that you would do underneath that concrete slab and the same membrane for moisture protection, but then just doing 2 layers of plywood essentially that thicken that up enough that you can install whatever flooring you want on top of it. And structurally, it's pretty much the same as the concrete anyway, and you don't have any concrete. It's all wood based. That seems to be a little controversial because people are like, no, I want this to be really solid and durable and last forever. But the reality is the wood will, once it's inside that thermal envelope and totally protected from the membrane that's controlling the moisture, it is going to last forever. And there are definitely people doing it and promoting it. And we'd like to push more in that direction, actually. I think our next one will try to be completely concrete free if possible.
Well, that would be such a big move because again, it's such a legacy industry, and it's one of the things that people. I mean, even when I went to go see some of the Earth ships, when I went to go see some of the Earth ships, one of their things that they use is concrete. It's just like a thing that, even though everything else is like built on garbage, basically, they use the concrete still, and I would say probably 99% of their buildings. So it's to be able to think beyond the concrete and to think beyond some of that stuff, I think is really admirable, and especially if people are doing it already and showing that it actually works.
All right.
Evan, what was your role here? Tell me what your role is.
My role on this project is the passive house consultant. I also did the mechanical and plumbing design for the HVAC and domestic hot water systems. And then I've also worn a hat where I've helped Jake and Nick a little in the field in doing some detailing work and collaborating with the architects and doing some preliminary blower door testing to confirm that the air barrier is complete and that we're achieving the performance that we want. We want to do that during construction so that by the time we get to the end of the construction, when we can't access any of the air leakage points, we make sure that they've already been sealed. So played a few different roles on this project, but it's part of the collaboration on these passive house projects.
Well, it's very exciting because, people talk about passive house design. There's a lot of different ways that people live around this area, a lot of innovative ways that people are living, but we hadn't really seen a passive design construction, so it's super cool. How long have you been a passive design consultant, or is it something that you just kind of rolled into from something else?
So I've been doing energy efficiency work for about 15 years in the building sector. And then about 4 years ago, I took a passive house training course and got certified as a passive house consultant. So there's actually 2 organizations. There's a Passive House Institute US, FIAS, and then there's the Passive House Institute in Germany. So there's 2 different certification agencies. They're separate. They have a similar type of certification. I'm affiliated with FIAS. This is actually my first passive house where I'm the consultant on, but
wow, you're breaking the ground.
All the principles of passive house building I use in my day-to-day work, and this is actually applying them into a certified project.
Now, what is the definition of passive house design?
So passive house is really a set of building principles. So it's called passive house, but it can be applied to any type of building. So it can be a home, a multifamily building, a school, a lab, a commercial building. So it's really a set of design principles and then a certification process that goes along with it. So of those principles, it's thermal control, so continuous insulation on the building or the home, air leakage control, and then a ventilation system, a balanced ventilation system to bring in fresh air and exhaust stale air. And then also comfort. There's a huge part about comfort and durability. So passive houses typically have triple pane windows, at least in our climate, to improve the thermal comfort for the occupants. And then there's also a whole focus on durability to make sure that we don't have any issues with moisture management in the building envelope.
Can we take a look at some of the things that you had been working on?
Yes, this house actually has a couple different air barriers, but there's a primary air barrier and then a secondary air barrier. The green zip sheathing up there is what we would call our primary weather resistive barrier. So that is really the primary control layer for water. We have multiple layers on top of that. As you can see, there's 2 layers of wood fiber insulation.
Which is kind of unique, right? The wood fiber insulation.
Yes.
Can you talk just a little bit about that and then go back to what you're
Sure,
saying?
yeah. So the wood fiber insulation, this product's actually coming out of Europe, but it's really exciting. We've got a company that's just setting up in Maine. So from all the logging industry there, that's kind of retiring the paper industry, and now they're retooling factories to do actually wood fiber insulation. So it's a wood composite material, so it performs fairly well. It doesn't perform as well as foam board, for example, but foam board's made out of oil-based and petroleum-based products. So what's really exciting about this is it's what we call carbon negative product. So we're actually storing carbon in our buildings, which is really important.
Is it technically like compostable? Like, can you compost it, or is it?
I do think there's some binders in there, so I wouldn't put that in my compost pile.
Yeah.
But it is a mostly wood-based, carbon-based material. So
and you said it's carbon storage. It's not like you're burning it or anything like that. So
and
you're storing it in your
So
house.
there's 2 aspects to the passive house building certification. Is really focused on operational carbon typically, so performance of the building, in terms of operation, but a lot of folks, including myself and the architects on this project, are also really focused on what's called upfront carbon. So buildings, the construction of buildings generates a lot of greenhouse gas emissions, a lot of CO2. And so we want to be using materials that actually reduce that release of CO2 into the atmosphere now, as well as through the operation of the building. So one of the materials is this wood fiber insulation.
Right. So I heard like everything basically above ground they were trying to use as far as the.
Yeah, correct. So like below grade, we're more limited on our products because of the moisture issues. But above grade, this is all 2 layers of wood fiber, and then on the inside, the project used dense packed cellulose, which is a recycled newspaper material. So that's also carbon storing. And so that really helps reduce what we call the upfront carbon of this building.
One of the things that I'm always like intrigued by is that, kind of seal some of the cracks and crevices, like this really like high performing tapes and things like that.
Yes,
It's mind blowing to me. It's like beyond duct tape,
It is beyond duct tape. We have a lot, tapes are one of my favorite things. So there's a lot of different types of tapes. Here on the outside, they're using this zip sheathing and tape, but on the inside, we can go in there in a minute, I think, but they used an Intello membrane, which is a high performance membrane that is an air barrier, but it also can be vapor open, which we want our assemblies to dry. If we ever get moisture inside the assembly from rain or a flashing detail that wasn't correct, we want to be able to make sure it can dry. And so there's some different tapes that we use for what is on the interior air barrier, which is actually our primary air control layer. On this project, as I was mentioning earlier, there's the zip sheathing, but that's actually not the primary air control layer. The primary air control layer is on the inside of the structural framing. And then there's actually a service cavity. So all the electrical and plumbing and everything is run in the service cavity, so it doesn't have to penetrate the primary air barrier.
Earlier in the build, Nick, the head contractor of the project, showed us how all the layers of the passive design house came together.
So our wall assembly starts with a 2x8. That's where we start our framing. And then we've got 7/16 zip outboard. And then we have a 4-inch, 100mm layer of Styco. And we install it in 2 sections, a 40mm, 60mm. We stagger the joints, it's all tongue and groove, so you get a little extra air seal out of that. Then we've got a 3/4 strap-in, which is our rain channel. And then we'll put we're using an LP Smart Side diamond coat finish on our siding. It'll be board and batten. And then inboard, we've got Intello wrap, which is going to be our main primary air barrier. Then we install a 1.5-inch service cavity. This allows us to get all of our receptacles and switches fully inside the air barrier.
Yeah.
And then in certain situations where we have to penetrate it for any water that needs to exit the building or any plumbing that is in the exterior wall, we use these special gaskets. They have a nice neoprene gasket that gives you a nice air seal.
Yeah, because anything that enters like outside, any of like the window edges, I see that you have this like tape along the edges to prevent any kind of airflow.
So you want to go upstairs?
Yeah, let's go.
Let's go upstairs.
Let's go up the attic.
We have an 18-inch rafter, TGI rafter.
Yeah, you can see the bottom of right here.
Yep. We had to oversize these with a 3.5-inch flange, which is just overkill on the engineering, but that's the only thing we could get the depth for the amount of blown-in insulation we need up there. So on our roof service cavity, we have 3.5-inch 2x4s that are lagged to the TJI in order to make another cavity for rock wool insulation. So there'll be another 3.5 inches of comfort bats in our roof system.
Wow.
And I also see that you put this barrier on first, and then you framed out all your walls.
Correct. So all our interior walls are pulled away from the house so that we can get insulation behind our walls, and that there's no, it makes a easier chase for our electrical as well.
Yeah, I was gonna say it's so much cleaner. The fact that you just have like a little compartment back here.
Right.
It just seems like it's neater, but you have a lot more space to work with because you're just building this kind of like really thick-walled house.
Yes.
Which, you know, I think is personally, I've never seen a passive house that was thin. It's like
it's
you
impossible.
Need those thick walls, yeah.
When we're done, we'll have about a 14-inch wall cavity or wall space.
Now, is there any significance with the awnings, or is this just more of a design element? Is it to keep like sun in or out, or anything like that?
So with these types of buildings, we want to be really careful about overheating them, but we also want to take advantage of the sun in our climate in the winter. So that's how these awnings were designed. So Stream kind of worked on making sure that between Stream and the energy modeling I did, we wanted to make sure that we're picking up the sun in the winter when the sun's low. So it's at a lower angle and it can come underneath the awning and get into the house. But then in the summer, it's up higher, and then it prevents that hot summer sun from getting inside the building.
And then one of the things that Sean and Rachel were mentioning, now I admitted, I was like, I'm so used to like, we got a house and it has these curtain windows, and I'm like, these are not as sizable as I thought. And they're like, no, we thought they were big. But it's south facing. You have more windows here than on the north side, and that's a kind of a common thing.
Yeah, so it's really about window placement. So one of the aspects that we did early in this project, part of the standard and part of the certification process is doing energy modeling. And so that's a really critical part of figuring out placement. Obviously, we want to place windows where the building occupants can enjoy them, but we want to make sure they're placed for high performance as well. So I built an energy model of this project really early on in an early part of design. And so we started to play with some of those aspects. Luckily, the Stream team, the architects, they understand how to do these projects. And so there was not a lot of back and forth that we had to do. We kind of hit it pretty well at the beginning, and we all kind of knew the direction we wanted to go. So there wasn't actually a lot of back and forth on location of stuff. But yeah, so typically you see a lot of windows on the south side and less on the north side because you want to pick up those solar gains in the winter. And if you have awnings, you actually can block the sun in the summer.
I mean, there's also probably a sort of sweet spot where it's like, I know even from our windows, being curtain windows, I'm like, and they're somewhat strategically placed, but it gets to be a greenhouse if you don't have some type of like blocking on your windows. So there's probably this middle ground or the sweet spot where it's like, is it too much or too little even on a south side?
Yeah, the south side's actually usually a little easier because the sun in the middle of the day in the summer is up high,
Right.
it's actually the west side that's the hardest in terms of thermal comfort
Interesting.
because the sun sets on the west, so it's at a much lower angle, and you get sun coming in those windows. So
Yeah.
that's actually part of the standard. So a lot of people think of it as a heating dominated standard, especially for our climate. But actually the biggest challenge for us on this project was meeting the cooling requirements. So we were having a little bit of trouble getting to the performance needed for cooling, which is also comfort, thermal comfort. So in this project, we actually do have air conditioning. It's not going to be used very much, but there is a way to condition the air in the summertime to cool it off.
Yeah, well, that's always good, even just having a backup, just so you know that you actually have it, especially when you're doing a build from the ground up, you can actually, put it in a little bit more easily.
Yes, correct.
And then are there anything other, like glazings or anything with the windows, aside from the fact that they are triple pane and they might have like argon gas or anything along those lines? Is there anything else that's special about them or that you need to take into account with a triple pane window?
So there usually you can get a bunch of different styles of glazing. So there's the frame performance and then there's the glazing performance, right? Which you were hinting at. So there's different what's called solar heat gains that you can use. So it's different films on the glazing that either allow more light through or less light through. And so there's a balance you can play where you want to pick up some of those solar gains, but you don't want too much. So these windows, I think we ended up, this glazing package is what's called solar heat gain coefficient of 0.49. We could have gone up to the 0.6, but that was where we were getting too much sun. And then some projects you might want to go down to something like a 0.3. So you do have those options, which is all part of the whole building performance and that modeling process that we work on.
I was going to say, it's like it's helpful actually to have a model up front, because even just like those little bits of numbers that you change, you could see almost immediately what the ramifications or the benefits of it would be.
Correct, yeah. So that's why we want to build that model early and then tweak it. A couple other things, these are, we'll call European style, although they have really big frames. So they're really, like you can see here, they've actually gone and made them smaller on this side.
I see,
But over here, they're bigger, and actually they've over-insulated it to some extent, which is great because what that's going to do is actually the frame is a lower performing, on these triple pane windows, the frame performs worse than the glazing. And so if we add insulation on top of it, we're actually increasing the performance. So that's something that we actually model as well in the model is what's called the psi value, where the connection between the window and the wall. And depending on how you detail that, you can have better performance.
And is this a type of fiberglass or?
This is actually extruded PVC, so it's a PVC window.
I see, okay.
But it has steel, has metal steel framing inside of it to give it a structural rigidity, which you wouldn't see in maybe your typical $99 PVC windows that you see more commonly.
And then is there a way to kind of upgrade the frame? Because you'd mentioned that this is usually, so you could maybe go with some other type of frame in order to upgrade the quality.
This is actually a pretty high performing, but you can use wood frame with aluminum clad, which are pretty cool windows, but they cost 3 to 4 times more.
Similar performance? Or better?
Similar performance, but the appearance is a little bit nicer. But these windows are really high performing, and our price point are very similar to your Andersons, your Pellers, your Marvins.
That's pretty impressive.
So that's very impressive.
Windows in general, expensive.
Yes, very expensive.
So,
the window package is usually one of the highest parts of a project.
Now this, I'm just feeling, this feels like velvet almost.
Yeah, it's very soft.
I just have never felt anything like that. I wouldn't be petting the pink insulation.
No.
Yeah, the wood fiber. It's on this side at least, where it's cut. Is there anything else from design perspective that you would point out here?
It's got a vented rain screen drainage plane, so that's just going to improve the performance of the siding. So if you get moisture back there, it can dry out, so that your siding will last longer, the paint will last longer. So that's not a requirement of passive house, but it's actually just a good building quality, durability thing to consider. Other things out here, we've got quite a bit of, this is a slab on grade, so there's no crawl space or basement, so there's actually quite a bit of insulation under the slab, and that serves 2 purposes. One, it improves performance, so we're not losing heat to the ground, but we're also improving the temperature of that slab. This home will just have a polished slab as their first floor. And so some people might find that cool to the touch, right? Because it's a concrete floor, but adding that insulation below the slab will help improve that temperature.
And I think you point out that's a place where a lot of people can lose heat in their house. So if somebody's building something, and even if they're not building like passive house design, what are some of those principles that they could use in their house? I mean, perhaps insulating the bottom, getting better windows, and what else is?
So I think that I would say the biggest thing is air leakage. And what's called a thermal bridge. So I'll touch on air leakage first. So air leakage is really critical because every bit of air that you lose to outside, you have to reheat that air or recool that air. So air control, I think, is number one, and that's actually really critical for performance, but also for durability of your assembly. So if you've got uncontrolled air leakage, either from the outside into your assembly or from the inside of your building out into your wall, you can carry moisture with that air, and then you can have issues with moisture in your wall system. And that's more of an issue when you build really insulated walls because they don't dry as quickly.
Right.
So air control, I think, is number one, both on new construction, but even existing buildings. So if anybody said, hey, what should I do to my house? Air seal it is what I would recommend. So we've done 2 blower door tests already on this house, and the last one we did was about 10 times less air leakage than currently required by code. That is going to dramatically improve comfort as well, because you don't have draft coming in and out of your house, and it's also going to just improve the overall efficiency of the project.
Just explain in layman's terms what a blower door test is for anybody who wants to know.
So a blower door test is basically we're using a fan. We're sealing off the house, and we're using a fan to either pressurize or depressurize the house, and then we are measuring the amount of air that is flowing through that fan. So we're basically exacerbating the air leaks in the house, but then measuring them. So we do it at a set pressure. So we create a pressure difference between the inside and the outside, and we measure how much air flows through that fan, and we can compare that across projects. And it tells us how well our air barrier is performing.
Now you increased your ability to keep the air in from the first test to the second test. Where did you find where the leakages were coming from, and then what did you do in order to compensate that?
Good question. So when we did the first test, the primary air control layer, which is this Intello membrane on the inside, was all accessible. So we had access to it, and that was the reason why we wanted to do the test at that time, because that's where we want to create our air barrier. So when we did the test, Jake and Nick and their crew were here, and we found some leaks immediately. So some tears, some rips, and they went around with tapes while we were running the fan, and they were able to seal those up. So we got to, I guess, 246 CFM at 50 pascals was the rate that we achieved, which was below what we wanted to achieve for this project. So we had already met our target. And then between that test and the next test, they actually didn't do any more taping of the air barrier, but they did the dense pack cellulose.
Oh, I see.
And that added an additional air control by filling those cavities with insulation. Even though cellulose isn't necessarily an air control material, just packing those cavities added some resistance to air.
Yeah, how do you even find where the leaks are? Like, is there, when you're doing your blower door test, is there like some color that comes up, or like is it finding like a needle in a haystack?
Good question. Well, so typically if you have a big temperature difference between inside and outside, you can use an infrared camera. We didn't, because the house was not heated yet, and so it was all the same temperature, so we did not use IR cameras. It's really just thinking about where they might be and feeling and looking for them is what we did here. You can also use theatrical fog, which I've done before, which is always fun. Put on some good jams and get the theatrical fog going.
Get some disco lights.
Exactly.
As well,
get the IR camera out and you got it all going.
Music on.
But we didn't need to do it.
Too, where if you're near a window, for example, you could feel because the house is being pressurized or depressurized.
Depressurized in this case,
The outside air wants to get in really badly. So you're able to go around and kind of feel
it.
Where the air's coming in, and then you can patch it.
Are there still some areas in the inside that we could see that has some of those layers?
I have not been here in a while, so let's check it out.
There might be some banging in there because they are doing some of the walls upstairs, I heard.
I'll kind of explain what we're looking at here. So so we have our window frame, and then we have our framing, our structural framing.
Or tape.
And then this white membrane is actually the primary air control layer. And that wraps behind this service cavity stud and across the wall to the next window, and it continues up the whole building as well. And then that's one of the tapes that was used. You can see there's 2 different style tapes depending on the application. One's easier than the other.
Yeah.
And then this is what we would call the service cavity. I'm gonna pop this out.
This is great. This insulation.
So this is mineral wool board insulation. So this is made out of spun rock, basically.
Yeah. So it's not. Is it like Roxol?
It's the same as Roxol, yes, but it's a different. It's a denser. Yeah. So back here, you can see. This is the primary air control layer that's been taped. You can even see some patches here, so this might be the spots that we were finding when we did our first blower door.
Yeah.
And this is where we call the service cavity, so that all the services can run in front of the primary control layer, but you still have space to hang drywall.
Right. Yeah. So you could cut your drywall and be able to take this out and then just easily have access to your electricity and stuff like that. Yep. Yeah. I mean, here you can see the windows and the sill also on the inside, and you just see actually really how thick from the sill inside to the sill outside, how thick these walls are. I mean, this is just so. If you took a cross section of this, it would be like a big sandwich right there.
Yeah, and so and what's nice is you can place your window. Ideally, you want to place it in the middle of your wall because that'll help the performance. But some folks would like a deeper sill, and they can move their window out a little bit, so you can kind of play with that.
Okay.
I also want I want to mention the balanced ventilation because that's really critical. So
people always ask, like, when a passive house, like, am I going to suffocate on the inside?
Exactly.
It's like the biggest concern, I think people say.
Well, so first off, passive house windows open.
Yeah.
Right. So we've got these are tilt and turn windows. So that's the tilt functionality. So there's always operable windows. We're not sealing these houses so that, or buildings so that there's no operable windows. So you can always open the window for fresh air. But what's great is that there's a balanced ventilation system with energy recovery. And so that is not yet installed, but.
Is that an ERV or an HRV?
It's called an ERV, Energy Recovery Ventilator.
Okay.
And that exchanges the moisture and heat from the leaving airstream into the incoming airstream.
So this is something that's always on at a minimum.
Always.
And so you are essentially using some energy in order to power that.
Correct.
And then I guess it's the person's choice, whoever owns the house, what energy they're using in order to be able to power that, right?
Yeah, so I'll touch on that in a second, but in terms of where they're going to get their energy from. But yeah, the energy recovery and continuous ventilation is a super critical part of these types of buildings because, as I was saying, we've made this insanely tight air barrier and these really high performing windows. We want to make sure that the house has fresh air and that we exhaust any contaminants. So this project, we've used a ducted range hood actually, so that if there's any contaminants on the cooktop, it is all electric, so there's no gas there, but even there you can be frying stuff and you want to get that out. So we've actually have a ducted range hood over the range.
I see. Is that where the...
That's where you can see up here, there's a vent. So we chose to do that because we believe that is going to be provide the best indoor air quality.
Right.
So you can choose to do continuous ventilation in the kitchen or a ducted range hood, and then actually we did both. So we're going to have a motorized damper on this, so there will be no leakage when the unit's not running, but when they need to exhaust contaminants off the cook surface, they have that option. And then there's an exhaust vent in each bathroom. And there's also one, this red capped one is going to be one for here as well. So this will be always exhausting air from this space. This one over here will be supplying air, and then there's a supply air in each bedroom. So every living space will have a supply air. So any room you're in, you'll have fresh air. And then the bathrooms, as I was mentioning, and then this one as well, will have exhaust.
I'm guessing these are strategically placed like in the center of the house?
So these are strategically placed for a variety of reasons. Okay. One, I wanted this one to be near the kitchen.
I see.
But also we have to get the ductwork here. We have another supply in this room over here, which is not yet in, but there'll be a supply air into this room.
Okay.
So that, as I said, every room that an occupant can be in will have supply air, and then there'll be exhaust air from the bathrooms in that kitchen. So.
Now, how does it work? Because if you're cooking and you're taking a lot of the air out of the house, what's going to happen? You're basically depressurizing the house.
Great question.
Is there anything you're doing to compensate for like the air that you're taking out of the house when you are using the range hood? Because, for example, I'm assuming that this ventilation system in here, it's basically filtering the air inside the house, or is it?
Correct. So this ventilation system is balanced. So the ERV is balanced. So that is a really good question, Sander. So this kitchen exhaust range hood is a standard. It's not they don't have a Viking stove with the commercial style range hood. But still, when it removes, say, 200 CFM or cubic feet per minute of air out of this house with this tight of an air barrier, you are going to depressurize your house. So that's actually something that we had to take into consideration. So there's going to be an outdoor air intake, what's called a makeup air system right over here. They're just starting to put it in.
Oh, I see.
So there will be a motorized damper on this air intake in unison with the exhaust air from the range hood, so that when that turns on, this opens and allows fresh air.
I thought that was a squirrel hole.
No, well, hopefully it doesn't become one, but no, it'll have a screen on the outside. But that was something, actually, that was one of the more complicated things in the design that I had to work through, because you got to have a whole bunch of little relays and figure out. And this will have its own fan as well. So sometimes you can just passively open up a hole, and obviously we're exhausting air, you're gonna pull air through. But once again, besides we were so tight on the air barrier, I wanted to make sure that we're mechanically bringing in that air so we're not depressurizing other parts of the air barrier.
Right, so even though you have windows here, technically in a passive house, you wouldn't need to open the windows for fresh air.
And actually, some people end up being so comfortable that they end up not opening their windows a lot.
Yeah.
People get really concerned about not being able to open their windows, and so they think they, I'm going to use my windows all the time, and they actually don't, because it's so comfortable, because there's so much fresh air. It's just a very comfortable space, and that's one of the big benefits. So there's a number of benefits to the passive house building principles. Big one is energy efficiency and reducing operation emissions, and building durability, but comfort and occupant experience is a really big important part.
One of the things about having a thick house and thick windows is that, we're next to the airport here. We're next to a big shopping center. We're next to a bunch of roads, and aside for the guys stomping upstairs and working in this house, it's very quiet.
Very quiet.
It feels like I'm in a sound studio right now. I could do really good audio recordings in here for voiceover. And, one of the things that I personally like about windows is when I'm able to open, I'm like, oh, there's a world out there. Like this. I hear bird song and frog song and everything, which I'm sure that's another reason. Of course, you have windows, obviously, to let light in and all that other kind of good stuff. But that is one of the things with passive house design is you get a lot of sound barrier, which is also very useful, especially if you're in like an urban or suburban area or just like a noisy area, you have a noisy neighbor. This is a multi-story house, and I know like in the old home that I grew up in that my dad built, like heat always rises and the heat always is hotter up on the top or towards the attic space or whatever. Is there a way to kind of cycle the air from there, or how do you have to deal with heat?
So a big reason why that happens is because you have air leakage, actually. Really? So you have air coming in the bottom of your building and pushing that hot air up out the top of your building. So because you don't have air leakage, you don't actually have that thermal stratification. And that's actually the other big benefit. So because this is such a high performing envelope, and we've got these high performing windows, you're gonna have a very even temperature throughout the house.
That's fascinating.
So we have that benefit. Now, for the heating and cooling system, we did decide to do 2 systems on this project. We could have gotten away with 1 system because the loads are so low, but there will be what's called a mini split head on this wall, and it'll have its own outdoor unit. So it'll be its own system for downstairs for heating and cooling, and then separately upstairs we have a ducted system that serves all the bedrooms and the office that's up there as well.
And then are they just using are they off grid, on grid, I
mentioned I would get back to that. So on this project, they are going to be installing a solar PV system on the garage that would be built once this is complete, and that'll basically, it's going to be designed to put this out in what's called net zero energy on an annual basis. So during the summer, they will overproduce. And they'll send those electrons back to the grid and to other folks who need them. And then in the winter, they'll probably pull some from the grid. They will have a battery backup, but one of the other benefits about passive buildings is you can lose power and your home or your building is going to stay comfortable for days. So in terms of if the power does ever go out here, they have the battery backup so they can run their ventilation system, but they will stay comfortable for a number of days as well.
Right. And because it's so energy efficient, they're barely, I would imagine, using energy, and they're probably getting energy appliances, Energy Star appliances and stuff like that.
So on a passive building, the plug loads, the appliance loads, and the occupant usage of the project actually ends up impacting the overall energy use more than like your heating and cooling loads, for example.
Just to get a sense of like cost, like how much cost does this amount of like insulation and extra windows and all that other kind of stuff put onto a typical house to get that 90% energy efficiency?
It's a good question. So as I mentioned earlier, these windows actually happen to be pretty price competitive compared to other windows. So that wasn't a big cost, but there obviously is additional cost to the performance of this wall, especially the wood fiber insulation. So that, for example, the wood fiber insulation was a choice that the owners made as well as the team. In terms of the embodied carbon, I mean, foam would have been a cheaper choice, but we wanted to make that choice for the environmental reasons. Typically, passive houses cost between 2 and 10% more than a conventional build. As you build bigger passive buildings, so multifamily, that price usually comes down because actually your performance, because you have a much bigger building, your wall performance isn't going to be quite as big because most apartments will share walls with other apartments.
Right, and that's actually something that we saw in the Ithaca Eco Village, where they had like a house next to a house, and because of that, they shared the wall, and they didn't have to put this wall here and this wall here when they're sharing.
Correct.
Yeah.
So typically on those projects, we see a little less of a cost impact. On single family homes, it is, it's a little bit greater, but you're gaining that, ignoring all the tremendous other benefits, you're actually on, if you're getting a 30-year mortgage, you're actually leveraging your energy savings as part of your monthly payments.
Now we're in the state of New York, and I'm sure other states differ, but is there any type of tax credits or benefits for doing a passive house design?
It depends on the state. So New York State does have a program for high performance homes through NYSERDA, which is New York State Energy Research and Development Authority. This project will get $2,500, not a lot of money on the big grand scheme of things.
Honestly, everything helps though.
But yeah, so there's also programs for heat pumps. This project's getting heat pumps, so there'll be some incentives to the utilities for that.
That's right.
And then there's also one of the great things about FIAS, which is the organization that we're certifying this project under, is they also require certification under some other national building programs. So the Energy Star Energy Star Single Family Homes Program, the DOE Zero Energy Ready Homes Program, and the EPA Indoor Air Plus program.
Do those require those certifications? Do they require money to certify them?
So there's two aspects. So there's the certification fees, which are actually pretty low, but it's the consultant fees that end up costing more. So obviously I'm the consultant. My fees, but there's a lot of benefits. So there's a lot of talk about should I certify or not. So some folks are building passive house style buildings and not going through certification. One of the benefits of certification is that you get an additional level of quality assurance, quality control. So this project has a third-party verifier. So it's work that I typically do on other projects, but because I was a passive house consultant on this, I can't act as the verifier. So there's actually a gentleman, Kevin Stack, who's doing the verification. So he's actually going to do the final blow door test. So we did some preliminary, but they're not the final. He'll actually come and do the final test. He's come and done what's called an open wall inspection. He's inspected all the insulation, made sure that it's complete and continuous. So there's that third-party verification, and obviously there's a fee to the consultant cost there.
Yeah, of course. I mean, everybody has to get paid at the end of the day. But I think it's good that if somebody is considering this, to do a house this way, even if they don't get it certified or not, what are the cost benefits for them and how can they prepare financially, for those extra added costs and be aware of those extra added costs up front, essentially.
Yep, that's a good point.
Yeah.
I will also say, you're building this house that's going to sit here for at least 100 years and hopefully longer, and all the aspects that we're talking about are really built into the house, right? And so people don't ever ask what's the payback on my new kitchen. So let's not it's not always good to talk about paybacks. It's the extra cost, you're going to have that value for forever, which is really helpful.
Right.
So.
I mean, this is very elucidating to me. Thank you so much for showing us this, the ins and outs of this, because that's questions that we definitely had. And I think when we're doing renovations on our own home, we're trying to pull some of these principles in order to be able to utilize them in older buildings that didn't have, some of this, put forward. So you're kind of trying to make it work with an old structure, and that's always sometimes a little harder than building from the ground up.
Building ground up is much easier, but applying these principles in a thoughtful manner on any project is really helpful. That's what I found. I mean, the knowledge that I've gained from working on passive house projects, as I mentioned before, I apply to all my other projects. So it's really helpful. I always encourage people to go to the trainings and learn about it, even if they don't certify a project, because it's the building science concepts. It's the first time I've mentioned building science, but it's really a building science certification. It's about how the building performs as a whole, how the walls perform, the windows perform, the ventilation systems perform. So it's a holistic approach to buildings, which is really important, because we as the occupants deserve to have a good, healthy, comfortable building to be in.
Yeah, absolutely. And I really like that this kind of even took the next level over, where you're looking at least from the ground up, how can we actually minimize our carbon footprint, and by using some of those wood fiber boards, insulated boards, which we had never seen or heard of. And I think that's pretty cool for people to say oh, that actually exists, or that's out there. And maybe it's a niche product, but from what it sounds like, the factory setting up in Maine, gives actually, because there's demand for it.
Right.
And then even this, I've seen Roxwool before, but this is a compressed version that I've never seen before. So I think sometimes when you get builders or contractors, they go to what they normally go to and that have been using for the last 10, 20, 30 years. And there's sometimes always these new little things that seem inconspicuous or innocuous, and then all of a sudden you're boom, but this is actually, plenty used in a place like this. Including the tapes. I'm so amazed by the tapes, the amount of different tapes that you guys use in order to just plug up the holes.
Yeah, and that's the other benefit. It's even if folks aren't building passive house, it's the knowledge base that the industry is gaining from these types of buildings that can be passed on to the contractors, to the clients, to the consultants, and we can continue to build better buildings, which is really what this is about, building better buildings for people to live in.
We hope this sheds some light on passive house design construction. Even if you're not planning on doing a passive house design, we think the principles can be applied to home renovations and new builds alike. We'll have more updates on our renovations soon, but in the meantime, stay tuned here for more fun projects around the Finger Lakes. We'll see you in the next episode.